Hello students, so we are doing exercise 21E, isn't it? So in our previous videos we have completed till question number 7, and today in this video we'll start from question number 8 onward. Okay, so let's begin. So this is question number 1 of 8. Prove that. So we are asked to prove this equation. In the left hand side we have tan 55 degree plus x, and we are asked to prove this equals to cot 35 degree minus x, isn't it? So before we do this, what I want you to understand is, suppose if I write minus 55, okay, plus x, then what I get is minus 55, minus into plus, minus 55, and minus into plus, minus x, isn't it? Just I'm giving an example. We must multiply with this minus sign, isn't it? Minus into plus, minus 55, and minus into plus, minus x. But we have plus x here, so we need plus x here. That means we must multiply minus 55 minus x. Okay, if we do this, what happens is minus into plus, minus 55, and minus into minus, plus x. Okay, we get this plus x here, isn't it? So I hope you got this. Now let us do this question. In the left hand side we have tan 55 plus x. So we are asked to prove this equals to cot 35 minus x, isn't it? So you can write this as tan, okay, 90 minus, okay, 90 minus 35. 90 minus 35 gives us 55, isn't it? 10 minus 5 is 5, and this becomes 8. 8 minus 3 is 5. 90 minus 35 gives us 55, and we have x here, so we must write minus x, because minus into minus gives us plus x. Minus into plus, see here, 90 minus into plus, minus 35, and minus into minus, plus x. This means 90 minus 35 is 55 plus x. The value should not change. 55 plus x should remain unchanged. Okay, so you can write tan 55 plus x in the form tan 90 minus 35 minus x, isn't it? So this gives us tan 90 minus theta. This is theta. Tan 90 minus theta. So tan 90 minus theta is cot theta, isn't it? Tan 90 minus theta equals to cot theta. We know this formula. So tan 90 minus theta is cot theta. What is theta? Theta is 35 minus x. 35 minus x, isn't it? So this is what we have in the right hand side. Cot 35 degree minus x. This equals to RHS. Hence proved. Okay, very easy, isn't it? Now let us do this question. Sec 70 minus theta equals to cosec 20 plus theta. Now we do the same thing here. Sec 70 minus theta, isn't it? So 90 minus 70. Oh, this 70 means 90 minus 20. 90 minus 20 gives us 70 plus theta. I'll explain this here. 90 minus within the bracket 20 plus theta, isn't it? So 90 minus into plus, minus 20, minus into plus, minus theta. So 90 minus 20 is 70, isn't it? 90 minus 20 is 70, and this minus theta comes here. So 70 minus theta should not change. 70 minus theta. This sec is this sec. And 70 minus theta is 90 minus 20 plus theta. Okay, 90 minus 20 plus theta gives us 70 minus theta, isn't it? So this is LHS. So sec 90 minus theta, this is 90 and this is theta. Sec 90 minus theta is cosec theta, isn't it? We know the formula. Sec 90 minus theta is cosec theta. What is theta? Theta is 20 plus theta. 20, this is 20, okay? 20 plus theta. So this is right hand side, isn't it? Equals to RHS, hence proved. Now let us do question number 3. Okay, now let us do question number 3 of 8. We have sine 28 plus a in the left hand side, and we are asked to prove this equals to cos 62 minus a, isn't it? The similar type of question as we have done in 1 and 2. See, we have 28 plus a. The value 28 plus a should not change after subtracting from 90. Okay, 90 minus 62 minus a. This gives us this. Let's check out whether it gives or not. This is 90 minus into plus. There is no sign in front of 62, means we must understand there is plus sign. So minus into plus is minus 62, and minus into minus means plus a. So 90 minus 62 is 28, isn't it? 10 minus 2 is 8, and this becomes 8. 8 minus 6 is 2. 28 plus a. So 28 plus a, this 28 plus a. Okay, after subtracting from 90, okay, we must get this 28 plus a. I hope you got me. Now let's proceed to solve this question. In the left hand side we have sine 28 degree plus a. So this is sine. Instead of 28 plus a, I can write 90 minus 62 minus a, isn't it? Minus into plus, minus 90 minus 62. 90 minus 62 minus a. 90 minus 62 is 28. 10 minus 2 is 8. 8 minus 6 is 2. So minus into minus is plus. Plus a, 28 plus a. The value 28 plus a should not change. So we have sine 90 minus theta. Sine 90 minus theta is cos theta, isn't it? So cos, what is theta? Theta is 62 minus a. Sine 90 minus theta. Okay, theta is 62 minus a. This is theta. Sine 90 minus theta is cos theta. That is 62 minus a. This is what we have in the right hand side, hence proved. Okay, now let us do question number 4. So question number 4 of 8, we have 1 upon 1 plus cos 90 minus a plus 1 upon 1 minus cos 90 minus a in the left hand side, and we are asked to prove this equals to 2 cosec square 90 minus a, isn't it? So let's solve this. In the left hand side we have LHS equals to 1 upon 1 plus cos 90 minus a plus 1 upon 1 minus cos 90 minus a. Okay, this is what we have in the left hand side, isn't it? So this can be written as 1 upon 1 plus cos 90 minus a is sin a, isn't it? Cos 90 minus a is sin a. Cos 90 minus theta is sin theta, plus 1 upon 1 minus cos 90 minus a is sin a. Okay, cos 90 minus a is sin a. So let's take the LCM of the denominators. So we must multiply these two numbers, isn't it? So a plus b into a minus b. When we multiply 1 plus sin a into 1 minus sin a, 1 plus sin a into 1 minus sin a, isn't it? This is actually a plus b into a minus b. This means a square minus b square. A plus b into a minus b is a square minus b square. So 1 square is 1, so we need not write square here. Okay, so 1 minus sin square a. Now 1 plus sin a into 1 minus sin a gives us this number. So 1 minus sin a into 1 is 1 minus sin a. So this is plus. 1 minus sin a into 1 plus sin a gives us this number. So 1 plus sin a into 1 is 1 plus sin a. Okay, so this minus sin a and plus sin a can be cancelled. So plus 1 and plus 1, this is plus 2 upon 1 minus sin square a is cos square a, isn't it? You know that sin square a plus cos square A equals to 1. So cos square A can be written as 1. So plus sin square A, if you transpose to the right hand side, becomes sin square A. 1 minus sin square A equals to cos square A. So instead of this 1 minus sin square A, I can write cos square A. So if I take this cos square A to the numerator, it becomes sec square A, because cos and sec are the reciprocal of each other. So 2 into sec square A. Are you getting me? This cos square A, when taken to the numerator, becomes sec square A. So 2 into sec square A. So let me continue here. 2 into sec square A, isn't it? So this is 2 into sec square A is actually cosec 90 minus A. So this is cosec square 90 minus A, because cosec 90 minus A is sec A. We know the formula, isn't it? Cosec 90 minus A is sec A, cosec 90 minus A. So sec square A can be written as cosec 90 minus A, because cosec 90 minus A is sec A. So cosec square 90 minus A is sec square A. So this 2 is this 2. So we have the same number in the right hand side, hence proved, equals to RHS. I hope you got this. Now let us do question number 5. Question number 5 of 8. So we are asked to prove this equals to 2 sec square 90 minus A, isn't it? So this question is similar to the previous question, that is question number 4. Okay, so let's do this. Left hand side, let's copy the left hand side first. LHS equals to 1 upon 1 plus sine 90 degree minus A plus 1 upon 1 minus sine 90 degree minus A. Okay, this is what we have in the left hand side. So 1 upon 1 plus this 1 plus sine 90 minus A is cos A, isn't it? Sine 90 minus A is cos A, plus 1 upon 1 minus sine 90 minus A is cos A. So let us take the LCM of the denominators, 1 plus cos A into 1 minus cos A. Okay, we must multiply these two numbers to take the LCM of the denominators, isn't it? We must multiply these two numbers to get the LCM of the denominators, 1 plus cos A into 1 minus cos A. So 1 plus cos A into 1 minus cos A gives us A plus B into A minus B, that is A square minus B square, isn't it? 1 square minus cos square A. So 1 square is actually 1, so we need not write a square. 1 minus cos square A. Okay, this is cos square A. So 1 plus cos A into 1 minus cos A gives us this number. So 1 minus cos A into 1 minus cos A. So this plus sign comes here. So 1 minus cos A into 1 plus cos A gives us this number. So 1 plus cos A into 1 plus cos A. Okay. So this minus cos A and plus cos A can be cancelled. So we have this plus 1. There is no sign in front of 1, means plus 1 plus 1, that is plus 2. So 1 minus cos square A is actually sin square A, isn't it? So let me continue this here. 2 upon sin square A. If we take the sin square A to the numerator, it becomes cosec square A, because sin square A and sin A and cosec A are reciprocal of each other. Okay, sin theta equals to 1 upon cosec theta, and cosec theta equals to 1 upon sin theta. We know this formula, isn't it? Sin theta and cosec theta are reciprocal of each other. So sin square A, if we take this number to the numerator, it becomes cosec square A. Okay, so this equals to 2. This 2 is already in the numerator, so we write 2 in the numerator. So sin square A, if we take to the numerator, it becomes cosec square A. Cosec square A. Okay, now this 2 is 2. Cosec square A means actually sec square 90 minus A, isn't it? Sec 90 minus A is cosec A. sec 90 minus a is cosec a. So sec square 90 minus a is cosec square a. So this is what we have in the right hand side, hence proved, equals to RHS. So I hope you got this. Now let us do the next question. Okay, let's do question number 9. So we have a plus b are complementary angles. Prove that cot b plus cos b equals to sec a cos b into 1 plus sin b. So we are asked to prove this equation, cot b plus cos b equals to this, isn't it? And the condition given to us is a and b are complementary angles. Okay, first let us understand what complementary angles mean. Suppose a and b are complementary angles. This means angle a plus angle b should give us 90 degree. Sum of these two complementary angles should be equal to 90 degree. Okay, so from this equation a plus b equals to 90 degree, because these two are complementary angles, angle a and angle b are complementary angles, so their sum should give us 90 degree. So from this equation, if I need angle a, I can write a equals to 90 minus b. This plus b goes to the right hand side and becomes minus b. And if I need angle b, so this is one case, and if I need angle b, b can be written as 90 plus a goes to the right hand side and becomes minus a. Okay, this is another condition. So if a and b are complementary angles, then a equals to 90 minus b and b equals to 90 minus a. Okay, I hope you got this. So you can write a plus b equals to 90 degree, because a and b are complementary angles. Okay, please remember a equals to 90 minus b and b equals to 90 minus a. Now, before we solve the questions from this question number 9, let us rewrite the formulas that we may need while solving the questions. Okay, so we know that number 1, sine 90 minus theta equals to cos theta. This is cos theta. Okay, cos theta. And number 2, cos 90 minus theta equals to sin theta. Similarly, number 3, tan 90 minus theta equals to cot theta. And number 4, cot 90 minus theta equals to tan theta. And number 5, sec 90 minus theta equals to cosec theta. And number 6, cosec 90 minus theta equals to sec theta. And I'll give you another formula also. Sin theta by cos theta equals to tan theta. Okay, that means cos theta by sin theta equals to cot theta. And sin theta and cosec theta are reciprocal of each other, so sin theta equals to 1 upon cosec theta. Similarly, cosec theta equals to 1 upon sin theta. And cos theta equals to 1 upon, let me not write this. Okay, tan theta equals to 1 upon cot theta. And sec theta equals to 1 upon cos theta. I did not write cosec theta because in the need of space, I don't have much space left here. If sin theta equals to 1 upon cosec theta, then that means cosec theta equals to 1 upon sin theta. Okay, if tan theta equals to 1 upon cot theta, that means cot theta equals to 1 upon tan theta. If sec theta equals to 1 upon cos theta, then cos theta equals to 1 upon sec theta. These sin, cosec, tan, cot and sec, cos are reciprocal of each other. Okay, so let's do this question. In the left hand side we have cot b plus cos b. So we are asked to use this and prove this equals to this, isn't it? So let's do this. Cot b means you can write cos b by sin b. Cot theta means cos theta by sin theta. Cot theta means cos theta by sin theta. So cot b means cos b by sin b, plus this cos b comes here, okay, as it is. We don't change anything. So we have 1 in the denominator of cos b. So let's take the LCM of 1 and sin b. The LCM will be sin b into 1 sin b, isn't it? So sin b into 1 gives us this sin b. So 1 into cos b is cos b plus comes here. 1 into sin b gives us this sin b. So sin b into cos b sin b, isn't it? So let us take this cos b common out. Cos b within the bracket, this cos b is taken out, so 1 remains within the bracket, plus this plus comes here. This cos b is taken out, so sin b remains within the bracket, sin b. And in the denominator we have sin b, isn't it? So this cos b, we don't change this because we need cos b here in the right hand side. So let's take this sin b to the numerator. See here, sin theta and cosec theta are reciprocal of each other. So if you take sin theta to the numerator, denominator, it becomes cosec theta, and if you take cosec theta from denominator to numerator, it becomes sin theta. Similarly, if sin theta was in the denominator, if you take that sin theta to the numerator, it becomes cosec theta, okay, and cosec theta when taken to the denominator becomes sin theta, okay. Sin theta and cosec theta are reciprocal of each other. So this sin theta, which is in the denominator, if I take this number to the numerator, this becomes cosec theta, that is cosec b, okay. And 1 plus sin b is already there. We need this 1 plus sin b, so we should not change this, okay. 1 plus sin b. Now this cosec b, this cosec b can be written as cosec 90 minus a, isn't it? Because we need this cos b and 1 plus sin b, but we do not need this cosec b, isn't it? So we must change this. So cosec b means cosec 90 minus a, because b means 90 minus a. B equals to, this 90 is already in the right hand side, this plus a goes to the right hand side and becomes minus a. B means 90 minus a. Cosec is cosec, b means 90 minus a. So this cos b we write as it is here, cos b, and 1 plus sin b as it is, 1 plus sin b. Now cosec 90 minus a, cosec 90 minus theta is sec theta, isn't it? So cosec 90 minus a is sec a, sec a. This is cos b into 1 plus sin b. So this is what we have in the right hand side, sec a cos b, 1 plus sin b. This equals to RHS, hence proved, okay. Now let us do question number 2. Okay, now let us do question number 2 of 9, okay. We have cot a cot b minus sin a cos b minus cos a sin b in the left hand side, and we are asked to prove this equals to 0, okay. So this question is very simple. So let's not change this cot a, we write cot a as it is, cot a. Cot b means cot 90 minus a, isn't it? B means 90 minus a, b equals to 90 plus a goes to the right hand side minus a, b equals to 90 minus a. So instead of b, this cot is this cot, instead of b I can write 90 minus a, minus sin a, I don't change this sin a, I copy as it is. Cos b means cos 90 minus a, okay, minus, I copy this cos a as it is, cos a. Sin b means sin 90 minus a, isn't it? So this cot a, cot 90 minus a, cot 90 minus theta is tan theta, isn't it? So cot 90 minus a is tan a, okay, minus sin a into cos 90 minus a is sin a, isn't it? Cos 90 minus theta is sin theta. So cos 90 minus a is sin a, minus this cos a we copy as it is. Sin 90 minus a, sin 90 minus a is cos theta, isn't it? So Sine 90 minus A is cos A. Okay, so cot A into tan A is 1, because we have tan A equals to 1 upon cot A, isn't it? We have tan A equals to 1 upon cot A, because tan A and cot A are opposite of each other, they are reciprocal of each other. So let's cross multiply this. Tan A into cot A, this gives us 1. Okay, tan A into cot A equals to 1. This means cot A into tan A is 1. So let us take this minus common. Minus, within the bracket remains sin A into sin A, sin A square A. At the same time, this minus changes to plus. Similarly, this minus changes to plus. Okay, cos A into cos A is cos square A. Because I took minus sign common, means the number which are negative becomes positive, and the number which are negative becomes positive, and the numbers which are positive becomes negative. The numbers which are positive becomes negative, and the numbers which are negative becomes positive. Okay, so this is negative, so this becomes positive here. This is negative here, so this becomes positive. So minus into plus, minus, minus into plus, minus. Okay, so this is 1 minus sin square A plus cos square A. Sin square A plus cos square A means 1, isn't it? So 1 minus 1 is 0. You know that sin square theta plus cos square theta equals to 1, isn't it? So sin square A, we must make sure that angles are same. Okay, sin square A plus cos square A, angles are same, A. Sin square A plus cos square A means 1. So 1 minus 1 is 0. So this is the right hand side, isn't it? So this equals to RHS, hence proved. Okay, now let us do the next question, that is 3. 3 of 9. Okay, we have cosec square A plus cosec square B in the left hand side, and we are asked to prove this equals to cosec square A into cosec square B, isn't it? So here we have plus sign, and here we need to make this plus sign into sign, multiplication sign, isn't it? So how can we do this? LHS equals to cosec square A plus cosec square B. So this cosec square A can be written as 1 upon sin square A, isn't it? Suppose if there is plus sign or minus sign in between the two numbers, and if you want to change this into sign, we must write the reciprocals, okay, and take the LCM. This is the simple trick. Okay, so cosec square A can be written as 1 upon sin square A, because sin theta and cosec theta are reciprocal of each other. So cosec square A is 1 upon sin square A, plus cosec square B is 1 upon sin square B, isn't it? Sin square B. Now let's take the LCM of the denominators, sin square A and sin square B. The LCM will be sin square A into sin square B, isn't it? Sin square A into sin square B. Now sin square A when multiplied with sin square B gives us this number. So sin square B into 1 sin square B plus sin square B multiplied with sin square A gives us this number. So sin square A into 1 sin square A. Okay, now we copy the sin square B as it is, sin square B plus sin square A means sin square 90 minus B. Okay, I am trying to make the angle same, sin 90 minus B, because A equals to let us take this plus B to the right hand side. 90 is already in the right hand side, so plus B goes to the right hand side and becomes minus B. A equals to 90 minus B. So this sin square, this is sin square. Okay, A means 90 minus B. In the denominator we have sin square A into sin square B, sin square A into sin square B. So this is sin square B plus sin square 90 minus theta. Sin 90 minus theta, sin 90 minus theta is cos theta. So sin square 90 minus theta is cos square theta. And what is theta? Theta is b. In the denominator we have sin square a into sin square b. Now the angles are same, b and b. So sin square theta plus cos square theta, isn't it? Angles are same. So this gives us sin square b plus cos square b means 1 upon sin square a into sin square b. Sin square a into sin square b. Now let us take this sin square a, sin square b to the numerator. Sin square a and cosec square a are the reciprocal of each other. So sin square a when taken to the numerator becomes cosec square a, cosec square a, and sin square b when taken to the numerator becomes cosec square b. Okay. So there is into sign, so into sign remains in between them. So this is what we have in the right hand side, isn't it? Equals to RHS, hence proved. Okay. So let's do question number 4. So question number 4 of 9. Okay, we have sin a plus sin b upon sin a minus sin b, and this in the left hand side, and we are asked to prove this equals to 2 upon sin square a minus 1, isn't it? So let's do this. LHS, first let us copy left hand side. Sin a plus sin b upon sin a minus sin b plus cos b minus cos a upon cos b plus cos a, isn't it? So let's copy this as it is. Okay, sin a plus sin b upon sin a minus sin b. Now let's change these numbers to sin. Okay, cos b means cos 90 minus a. Cos b means cos 90 minus a, isn't it? B means 90 minus a. B means 90 plus a goes to the right hand side becomes b. B means 90 minus a, isn't it? Plus a goes to the right hand side and becomes minus a. So cos b is cos 90 minus a. Cos 90 minus a is actually sin a, isn't it? Cos 90 minus a is sin a. Okay, so let us do quickly. Cos b can be written as, okay, this plus is here, so cos b is actually sin a minus cos a is sin b, isn't it? The similar way, cos a means cos 90 minus b. Cos 90 minus b is sin b. So this cos b is sin a plus cos a is sin b, isn't it? Now we have sin a minus sin b and sin a plus sin b in the denominator. So let us take the LCM of the denominators. So we must multiply these two numbers, isn't it? Sin a minus sin b and sin a plus sin b. So when we multiply these two numbers, what we get is a minus b into a plus b. This means a square minus b square, sin square b. So sin a minus sin b into sin a plus sin b gives us this number. This means sin a plus sin b into sin a plus sin b. This number into this, sin a plus sin b into sin a plus sin b. This means sin a plus sin b whole square, isn't it? The same numbers, a into a is a square. So plus this into this gives us this. This means this should be multiplied with this. So sin a minus sin b into sin a minus sin b gives us sin a minus sin b whole squared, isn't it? A, let's suppose this as a and this as a. A into a is a squared, isn't it? So we have sin a plus sin b whole squared. Let us put the formula a plus b whole squared here. I'll start from here. Okay, a plus b whole square means a square plus 2ab, a and b is sin b, 2ab plus b square. Now this plus comes here, So a minus b whole square means a square minus 2ab plus b square, isn't it? A square minus 2ab plus b square, and in the denominator we have sin square a minus sin square b. So sin square a minus sin square b is actually cos square a, isn't it? Sin square b is actually cos square a, because sin square b means sin square 90 minus a. B can be written as 90 minus a. B can be written as 90 minus a. So sin 90 minus a is cos a. So this is square. So cos square a. Sin square b is cos square a. Okay. I hope you are getting me. Now we have 2 sin a sin b. This is plus, and 2 sin a sin b. This is minus. So we can cancel this out. Plus and minus the same number. So sin square a plus sin square a. This gives us 2 sin square a plus sin square b and sin square b. See here, sin square a, sin square a. 2 sin square a, sin square b, sin square b. Both are positive. See here, sin square b plus sin square b, 2 sin square b, sin square b, isn't it? So we need 2 in the numerator, isn't it? So sin square a minus cos square a means 1 minus sin square a. Cos square a means 1 minus sin square a. We know the formula sin square a, sin square theta plus cos square theta equals to 1. So sin square theta equals to cos square theta equals to cos square theta equals to 1 minus the sin square theta goes to the right hand side, isn't it? So cos square theta is 1 minus sin square theta. That means cos square is 1 minus sin square a. This minus is this minus. Cos square a means 1 minus sin square a. Okay. So now let me erase this. Okay. We have 2 and 2 common, isn't it? 2 sin square a plus 2 sin square b. Let us take the 2 common out. Sin square a, sin square a plus now this is sin square b, isn't it? Sin square b can be written as cos square a. Sin square b can be written as cos square a. Sin square b means sin square 90 minus a, because 90 minus a gives us b. So b means 90 minus a. So sin 90 minus a is cos square a. Sin square b can be written as cos square a. Okay. So instead of this 2 is taken common out, so 2 we need not write this 2 again. So instead of this sin square b, instead of this sin square b, I can write cos square a. In the denominator, sin square a minus into plus. There is plus sign in front of 1. Okay, no sign means plus sign. Minus into plus, minus, isn't it? So minus into minus, minus into minus is plus, plus sin square a. Minus, okay, minus into plus, minus 1. This 1 comes here. So minus into minus, plus sin square a, plus sin square a, isn't it? So 2 into sin square a plus cos square a. The angles are same, a. So sin square a plus cos square a means 1 upon this sin square a is plus, and this sin square a is also plus. So plus sin square a plus sin square a means 2 sin square a, and this is minus 1. Okay. So 2 1s are 2 in the numerator, and in the denominator we have 2 sin square a minus 1. So this is what we have in the right hand side, hence proved. This equals to RHS. I hope you got this. Okay, please take the screenshot. Thank you so much for watching this video. I'll upload the remaining question in the next video. Okay.